All right, so once again, good afternoon, good evening, actually, to everyone. I hope you're all doing well. Please excuse my voice at the moment. I have the flu, so I sound a bit under the weather. Please excuse me for that, but I'm going to try and talk as clearly, as crisply as possible. I am going to start the session with giving you the scope of your exam. We are allowed to tell you that these are the sections that are covered, so I'm going to project it onto the screen for you. Please, can I ask that you make note of it? You are also able to download this. So if you look at the right-hand corner, the top right-hand corner of the screen, next to the, well, I'm assuming from your view, you can't see all of the same options that I can, but there should be a download button. So an arrow facing down that will allow you to download the document that you see on the screen at the moment. So if you're able to, please do download this document. If not, you can take a picture if you'd like, or just make sure that you're taking it down so that you're aware of the options in your exam. So it is much more straightforward than it used to be in the previous years, where you now have the advantage of knowing exactly what will come out in your exam. You know which sections you can focus on. You're actually able to leave out certain sections, which really does work to your advantage because you're now able to choose between certain learning units under certain sections in the exam. Now, obviously, it's going to be according to what your strengths are, which sections you find easier, which you are more comfortable with. So please do choose wisely when it comes to the sections that do have options. And I'm going to discuss that with you now. So let's have a look at what you see up on the screen. Your exam is a 2-hour exam. It is written on campus, as you naturally would have known already. It is 120 marks. So here at the top, I'm just going to highlight that for you. So there's 4 sections in this exam. The structure is different to previous years because this is the first year that you will now be given options. So although we will be working through the 2022 exam in today's session, the structure of it, the look of the paper is not going to be the same because of the fact that you now have options, but the content is exactly the same. So there's no difference in the actual module as a whole in terms of content-wise. It's still the same 9 learning units as it previously was. It's just that the way in which you're being tested now will differ. So the idea is the same as your assignment 2, where you did have the option to choose between ungrouped or grouped data. Exactly the same idea here. You just have to select between 2 options that are given to you in 3 out of the 4 sections in the exam. So there's 4 sections in total, A, B, C, D. Section A is entirely compulsory. It makes up 60 out of the 120 marks. So 50% of your paper will be compulsory. The first section of the exam, we also, and again, you're so lucky in this sense because we're also allowed to tell you exactly which learning units these will be. So the 3 learning units that make up section A are learning unit 1, which is your basic theory. It's your introductory concepts. That is 20 marks. This should be along the same lines of your assignment 1, where you had multiple choice questions and matching columns. They generally don't ask you short questions or explanations in detail, but if it has to come out as anything other than multiple choice or matching columns, it would just be a short question such as define quantitative techniques, or define the difference, or list out, explain the difference between qualitative and quantitative data, or explain what your inferential statistics is all about, that kind of thing. Very basic stuff, just a short explanation that's required, but mainly it should be centered around the same type of questions you had in your assignment 1, which is your matching columns and your multiple choice questions. So this is for 20 marks. It's purely theory based. Learning Unit 2 is the next section that's compulsory. This is your index numbers. So your index values or your index numbers, remember, There is a formula sheet that will be provided to you, but not all of the formulas for Learning Unit 2 are included in the formula sheet. So in your formula sheet, you will see that there are formulas for, and I am also going to be projecting that just now as we go along to show you what you can expect. But for Learning Unit 2 in particular, you will find that you have formulas for all of your price indexes, but none of the quantity indexes. So you do need to know that. Please make note of it. It is a compulsory section. So you will have to know these formulas in case you do get asked any of these. So you will need to know the quantity index formulas, quantity indexes, and also of your price indexes, the only one that's not included, so I'm going to say and, is your unweighted price index. So this also does make it easy for you again in the sense that you do now know what you will need to know, what you will need to learn for the exam in terms of Learning Unit 2. You have 8 formula in total for the learning units for index values. 3 of them are included in your formula sheet. The remaining 5 you will have to learn. So that's all of the quantity indexes. There's 4 quantity indexes, and then your unweighted price index. So that's 5 in total that you will need to learn. So index values makes up the next 20 marks of your compulsory section, section A. And the last section in section A, or the last learning unit in section A, is learning unit 4, which is your linear regression calculations. So this is honestly, all 3 of them are the easiest of all of the learning units that they have made compulsory here. So again, it really does work to your advantage. This is the first year that they have set the papers in such a way where you have options. So it really is going to be quite beneficial to you to have options. And then also, as I said, in this compulsory section, all 3 learning units that are compulsory are the easiest of the module as a whole. So Learning Unit 4, which is your linear regression, is also worth 20 marks. And this is going to be your basic questions like calculating the values that go into the regression function, which is y is equal to a plus bx. We'll do an example of it in the paper as we go along just now. So main questions here is to calculate the values of a and b in the formula, and then also to calculate your correlation coefficient, which is R, and then also the coefficient of determination, which is R squared. Those are the 4 most common calculations that they can ask you. And then also, once you've calculated your regression equation, they could ask you to forecast using that equation. So these are the sections that are compulsory. They are quite straightforward. Nothing really complex here where they can ask it to you differently or there's excessive amount of work that needs to be done. So it really is quite beneficial to have those 3 as the 3 learning units that are compulsory. So it makes it easy for you to score those 60 marks initially, those compulsory marks, and then it just eases it for you a bit as you go into the remaining sections, because you have the easy stuff out of the way and you're pretty much guaranteed most of those 60 marks. And then you know that the rest of it is obviously just reinforcing, just adding on to that. So now let's look at the sections that are well, not all optional, just each one of these sections have questions that you will choose from. So here you have in section B, this is for 20 marks. As you can see, you have an option between, and this was the same as your assignment 2, an option between your grouped data and your ungrouped data. So you are going to choose one or the other. Please pay careful attention to that, not both of them. The structure of the paper is in such a way that you will only have time to choose between each of these remaining 3 sections. So you will choose one from section C, one from section B, one from section C, one from section D. You obviously won't have the time allocation to answer everything in each one of these remaining sections. So section B is a choice between your grouped and your ungrouped data. You will choose between those, and then that's also your 20-mark question. Then you have learning unit. So section C is what we're looking at now, 20 marks as well. So you'll see that the remaining sections B, C, and D are all for 20 marks each. And then section C has 2 different questions, but it looks at 3 different learning units. So in section C, the first question is based on learning unit 5, and these are your basic probability equations or basic probability questions, like having a two-way contingency table where they would ask you questions such as, what is the probability of selecting a male who prefers Vodacom, for instance? So just some of those basic questions. Again, you would have come across these. So as you are studying, you'll have an idea of what I'm referring to there. So you have your contingency tables or your cross tabulation tables, and then you have stuff like your probability trees being drawn up, your permutation and combination rules. So this is learning unit 5. And then the second option is 2 learning units combined. So you have learning unit 6 and learning unit 7 combined. And learning unit 6 is based on your discrete and continuous distributions. These are your binomial, your Poisson distributions. Learning unit 7 is your sampling distributions, which is where you would have that 3-step process of determining the rule, calculating the test statistic, and at the end applying the rule that had been identified and calculating your final probability. But again, as we go along here, I will point out to you for each learning unit, for each question, which learning unit it comes from, and what type of question you can expect to appear in your exam specific to that learning unit. So, sorry, I will take questions at the end. I'm almost done with this. So section C is then, as I said, 2 questions to choose from, but it is 3 learning units that is being covered here. Learning unit 5 is the first question. The second question is based on 2 learning units, learning unit 6 and 7. Okay, so again here, you are going to choose one or the other. It will either be the first question under section C, which will be based on your Learn Unit 5 content, or the other question, which is then based on your binomial and Poisson, as well as your sampling distributions. And then the last section D, also worth 20 marks, as we said earlier. This is based on the last 2 learning units of the module as a whole. So learning unit 8 is the first one. This is hypothesis testing. Or you are going to select learning unit 9, which is your chi-squared statistics. So again, here you will choose one or the other. Your hypothesis testing is the 5-step process. Your chi-square distributions is the same 5-step process, but it's just based on a positively skewed data set. And again, as we go along, I'll show you in the past paper the examples of those. So throughout here, you have 1 compulsory section, section A, based on 3 learning units, learning unit 1, 2, and 4. And those are 20 marks each, which gives you your collective total of 60 marks for the first section. Then you have section B, C, and D, which is all 20 marks each. You have a choice under each section. You will only choose 1 question to answer, and each of those questions will be worth 20 marks, which gives you your collective total of 120. Okay, so any questions from your side?
Hello, ma'am. Can you hear me?
Yes, I can.
Ma'am, when studying for the exam, can we like choose the learning units we want to study according to the paper that you just explained now, like for example, section B is learning unit is group data or ungroup data. Can we choose to study one, or must we still study both?
Yes, so I was saying that at the beginning of the session that ideally, because you will be able to now identify that these are the sections you would like to answer, it obviously enables you then to eliminate whatever is not your option. So obviously here you essentially can eliminate 3 to 4 learning units, just dependent on what you select in section C. So essentially, if you're choosing, for instance, ungroup data here, learning unit 5 here, and learning unit 8 here, you are basically eliminating 6 and 7, grouped data here, and in the last one, learning unit 9. So you've basically eliminated 4 learning units that you need to study. So essentially, it is up to you. You are obviously knowing this now. You're going into it having learned only exactly what you are answering in the paper. So yes, you can definitely eliminate whatever you would like to.
Okay, thank you, ma'am.
Yes, for the chi-squared statistics or chi-squared distributions, you will round off to 2 decimal places. In fact, for the paper as a whole, as a general rule on the first page, as you would have seen in your assignments and so on, or any other exams you've written, it is 2 decimal places unless a specific question says to you otherwise. So if they do say to you for some reason, round off to a whole number, or if they say to you, and do pay attention to those little things like them saying percentages or to a whole number and so on, pay attention to the unit of measurement that they're asking you for, because a lot of the time they do specifically say that. They'll say to you, answer the following section as a percentage to 2 decimal places, or as a whole number but a percentage. So do pay attention to that, but the general rule is 2 decimal places. Except for your probability trees, when you are drawing up the probability trees and calculating the outcomes of it on the tree itself, those will remain as simple fractions unless they ask you otherwise. Only if you're calculating a probability based on the probability tree, then can you leave it as a 2 decimal place answer. Any other questions from anyone?
Hi, Akira, can you hear me?
That sorry, just give me 1 second to answer Prima's question. So in terms of your question says for section C, there are 2 questions. The first one will be learning unit 5. I'm assuming that it will be exactly as they've listed it out here, because this did come from the central academic team who sets these exams, but I honestly cannot guarantee that. You will obviously still definitely, it's a choice, but I don't know whether it will be learning unit 6 and 7 first as option 1 under section C, or whether learning unit 5 will be the first option like they've stated it here. But I'm assuming that they have given you this structure according to how it was set. So I'm assuming it should be in pretty much the same way that it's listed out here. Yes, I am going to show you the formula sheet in a minute, and you'll also be able to download that as well from the screen. So please do make use of that option. I just wanted to answer, Irfan, is that you? What was your question?
Yes, that's me. For some of the past papers and exercises in the workbook, for the chai test, they round off the observed frequency and expected frequency to 2 decimal places, but they round off the sum statistic to 3 decimal places. Is that what we must do?
No, you can stick to 2 decimal places because well, our memos have them as 2 decimal places. So that's what the standard is here.
Because when you work out the X critical value, it comes as 3 decimal places on the table.
So you can round those off to 2 decimal places as well. It's just to give you your final answer as a 2 decimal place as well. So when you're calculating your expected frequencies, leave those as 2 decimals. The critical limits that you get from your tables, those are standard values. You are not calculating those. Those will be provided to you in the exam. I'm going to show it to you in the formula sheet just now, but those critical limits you're not calculating. You are only calculating the expected frequencies, and those you have to leave as 2 decimals.
Okay. I'm just saying that in the papers, the sample statistic itself, at the thing that you calculate right at the end, was rounded off to 3 decimal places.
Yes, for the purpose of your exams, you'll round them off to 2 decimals.
Okay, thank you.
Okay, perfect. So I'm going to show you the formula sheet just very quickly so that you can have an idea of what to expect. This is a general formula sheet. It's the same one that you would have seen in your assignments. It is the same one that will appear in your exam as well. So your formula sheet will be broken up into sections. So you'll have headings for each one of them that can help you identify which learning unit it is specific to as well. So if you look at this, the first one, in fact, this whole page pertains to learning unit 3, which is your grouped and your ungrouped data. Now, unfortunately, they're not going to be able to tell you what is specific to grouped and what is specific to ungrouped. That naturally is up to you. So although the formulas are here, you do need to know which one applies to which specific category. So for instance, you need to know that these 3, for example, these 3 here are for grouped data. This here is for ungrouped data. So I'm just going to say UD here, for example, ungrouped data. This is group data. So they're all mixed up. You need to then look at what is specific to each each section of the learning unit, grouped and ungrouped. And I think there's just a few more of it. Yes, so there's one more here on the last page as well at the top, and that's all for learning unit 3. So that's your grouped and your ungrouped data mixed up. So please do make note of that. Again, as I said, you can download this. So on the right-hand corner of your screen, you'll see the down arrow. This will enable you to download the formula sheet that you see up here, so you can make use of that for studying purposes. And then here, as you can see again, they've given you the heading of your probability distributions because this is a learning unit on its own. So they've given you the heading probability distributions, but obviously it's important that you know that this is specific to this learning unit. So this is dealing with your section C, where you have learning units 6 and 7, your binomial Poisson distributions. For instance, this is the binomial distribution formula. This is the Poisson distribution formula, and so on. So again, although the formulas are here, it obviously is important that you know what category or what learning unit they fall into, because it is pointless if you just have the formula sheet there, but you don't know what is specific to each learning unit. So this is why it will be beneficial for you to have a copy of this with you while you're studying, so that you know that this is where it lies in the formula sheet, and this is where it came from, in which section, in which learning unit, and then you're able to piece them together in your exam. So that's the next one. Then you have linear regression and correlation analysis as the next set of formulas. Here, everything has been provided for this learning unit. So the formulas, here, everything has been provided for this learning unit. So this is the first section, section A, the compulsory section in your exam. So this is the formula for B, which is also known as B1. This is the formula for A. This is the formula for R, which is your correlation coefficient. And then R squared is your coefficient of determination. So pretty much everything you need for learning unit 4 will be there. Then you have hypothesis testing. So again here, although you do have the formulas, you obviously need to know what is specific to what here. Also, what's important is they grouped this last formula, which is your chi-squared statistic formula. This is the formula for the chi-squared statistic. They've grouped it into the category of hypothesis testing. So please pay attention to that. This is the formula you'll need for Learning Unit 9. These are the formulas for Learning Unit 8. So the remaining ones here are for Learning Unit 8. It's actually just this one and this one that you need for Learning Unit 8. And again, although the formulas are there, it's important that you'll be able to identify that this is for mean and this is for a proportion. So please keep this with you when you are studying. It obviously will make it easy for you to identify which is which. And then obviously in your exam, you can refer back to your formula sheet and you know exactly what applies to each learning unit. And then here, the last part of your formula sheet is your index numbers. So this is Learning Unit 2. And as I pointed out to you, this is 3 formulas out of the 8 that you will need to know. So the remaining 5 I wrote down on the screen earlier would be all of your quantity index formulas as well as your unweighted price. So please pay attention to that. Only 3 out of the 3 out of the 8 are here. The remaining 5 you will need to learn. Those are actually the only formulas that are not in the formula sheet. And then also Learning Unit 5 content. All of your different rules that will apply, the different types of events that occur, none of those formulas or rules are in the formula sheet. You do need to know these. So please make note of that. Learning Unit 5 formula as well as so I'm just going to write that here. And as I said, the quantity indexes, all of them, as well as the unweighted price. So this is what you will need to know in terms of your formulas. So quantity indexes, unweighted price index, and everything from Learning Unit 5. Then the next 3 slides or pages that you'll see up on the screen are also going to be in your formula sheet. They are table 1, 2, and 3 of your appendix. They pertain to specific learning units. So obviously dependent on what you are selecting to learn for your exam, this would be used. So this first table is used for learning unit 6. This is table 1 of your appendix. They will provide it to you. You will also find it at the back of your textbook. But again, obviously, because these are critical values that are already calculated, it's not necessary for you to calculate any of them. As you can see, there are too many to calculate anyway. And the second one is table 2, which is specific to learning unit 8, your hypothesis testing. And then the last table 3 is specific to your chi-squared distributions. So they will also provide you with those. All 3 tables and all of the formulas you saw earlier on will be at the back of your exam paper. All right, any questions in terms of your formula sheet? Please don't forget to download it if you haven't done so already. Yes, you are correct. There is a table that you will need to know, but it's not from the appendix of your um, textbook. It's within the textbook. So if you look at this that you see up on the screen, this table here, I think it's on page 221 of your textbook, if I'm not mistaken, but thereabout, it's under the section of hypothesis testing. So this table you will need to know. They are not going to provide you with the values of this table. You don't have to worry about the stuff at the bottom here, but this table, page 221 of your textbook, you'll need to know all of the values specific to the type of test that is being carried out. So here's the type of test. It's either two-tailed, one-sided lower-tailed, one-sided upper-tailed, and then you have your specific significance level, which they will give to you. It's either 1%, 5%, or 10% level of significance. So this is for hypothesis testing. No, so Stephanie, this was from what the module previously used to be. This is, so previously this module used to be Stats A and Stats B, and it's now a combined module, so it's just one Stats module, not A and B, and financial maths used to be part of Stats A, but it's no longer part of the module. Okay, perfect. So I'm going to then go ahead and get started with the 2022 exam if there are no other questions. But if you do have a question, please just pop me a message into the chat, or you can also raise your hand. I am going to try and, so what I think might work better is I will complete each question and then take any questions that you have at the end of the question. But if you feel like there is something that you need to know while I'm explaining, then please do just press the raise your hand icon and I can tend to it then. But if it's smooth sailing throughout, then I will just go through the entire question, and then at the end, if you have any questions, you can let me know. Yes, the exam is on the 6th of July. All right, so as I was pointing out to you earlier, this is the first year that the structure of your exam has changed, in the sense that the setup of it has changed, not the actual content. So it's still the exact same content that has previously been covered last year, except for there are now options. So what you see in this exam up on the screen, the 2022 exam, will be set out a little differently to what you can expect in your exam. Naturally, this is the first year that it will be set out in this way, so there is no previous paper that we can look at to give you an idea of how it will look. So you are the guinea pigs for the first time that they are rolling out options in the exam, in the tests and assignments as well, for the full-time students and you guys as well. So it obviously is new. I do expect that students will do pretty well, though, given the fact that you do now have those options. So you are able to eliminate whatever is not necessary for you, and you're obviously narrowing it down to whatever you found was easier, whatever your strong points were. And obviously, that makes it easier for you to do a lot better than students had in previous years. So I do hope that it will be a good change. I have seen the change being quite effective so far, so I'm assuming that it will be the same with the exam as well. I don't expect it to be difficult compared to last year because, as I said, the content is exactly the same. It's just the question, well, the fact that you now have those options is just the only difference from last year. So the type of questions exactly the same. The learning unit itself exactly the same. Literally just the fact that you now have options is what's different. So this that you see up on the screen was how it was previously tested. Everything was compulsory. There are, I think, 8 questions in this exam. Remember, last year nothing was optional. So pretty much everything from learning unit 1 to 9 was examinable. So you'll see here that we'll work through every type of question that can be asked for each learning unit. It does give you a good indication of what to expect in terms of the questions. And it's the same to our exam, 120 marks. So I was pointing out earlier that as a general rule, you will give all of your final answers to 2 decimal places unless they indicate otherwise for a particular question. They will specifically say to you ahead of a question, this is how they need you to answer it if it's different from the normal 2 decimal place. If they don't say anything, then you can just stick to your 2 decimal place answers. All right, so let's get started. The first question is purely theory based. It is looking at multiple choice and matching column questions for learning unit 1. This is also the same type of thing you can expect for section A of your exam, which has learning unit 1 included, your introductory concepts, your basic explanations and definitions and so on. It obviously is preferable that they do ask it to you in this way because you then are just selecting from your answers instead of having to know full on definitions and stating or writing out short answers. So let's hope that they do stick to this. So the first question says to you that they're looking at the difference in weight between a father and his oldest child. And this is an example of, so here weight is a numerical value. So that would obviously eliminate qualitative as the answer. So it definitely cannot be the first two. It's definitely quantitative. And then weight can be classified as a decimal. So that would obviously eliminate this one because discrete data is where it can only be a whole number. It cannot be decimals and fractions and so on. So that obviously then leaves us with the last one, which is quantitative and continuous. And continuous variables are those that are numeric and can be decimals, fractions, negative, and so forth. So that's the first one. The next one then says the random variable size of milkshake. Small, medium, large, and so on is an example of. So this would be ordinal data. And this is because ordinal data, firstly, is non-numeric in nature, which is the same as the information they've given you, the random variable they've given you here. It's not numeric, it's looking at the size in terms of small, medium, large, and so forth. And the second thing that qualifies it as being ordinal is the fact that there's some sort of difference in ranking in terms of each one of the options, small, medium, large, in the sense that medium is bigger than small, large is bigger than medium, extra large would be bigger than large, and so on. So there's some sort of ranking between your values, and this is what classifies it as being ordinal. Then the next one says data obtained specifically for the purpose at hand is referred to as, and this would be primary data because this is where data is gathered specifically for some sort of research that's being carried out. So it's for the purpose at hand. Then the next one says that the number of passengers on a flight from Durban to Cape Town is an example of. So here it also is part of the explanation that I gave to you at the top here for the first one. You're looking at a number of passengers, so it cannot be qualitative. Then you're also, and it also can't be ordinal because ordinal is qualitative as well. It's lists or categories of information. So this is looking at a number. It cannot be a list or a category of information. Then that leaves us with discrete or continuous. And I said to you that discrete variables are those that can only be whole numbers. They cannot be fractions, decimals, negative, and so forth. So this is continuous, where it can be negative, fractions, decimals, and a number of people cannot be a fraction. It cannot be a negative. It cannot be a decimal. So it cannot be continuous either. It has to be discrete. Then the last one is the weakest form of data with regard to statistical analysis. So the weakest form of data is nominal scale data. And if you had to list that in order from weakest to strongest, the weakest form is nominal, then it's ordinal, then it's interval, and then ratio. Is nominal, then it's ordinal, then it's interval, and then ratio. So these are your 4 measurement scales from weakest to strongest, and they asked you for the weakest, so that would have been nominal. So those are your 5 multiple choice questions. On the next page, you're going to see your matching columns. So it says you match the definition in column X with the correct term in column Y. 2 marks will be awarded for each answer. So this whole question was also for 20 marks. Again, it is a good indication of what you can expect in section A of your exam for Learning Unit 1's content, because it also will be 20 marks, and it's also based on all of this theory from Learning Unit 1. So it really is a good indicator of how you can expect the questions to look, or the setup of your exam to look for Learning Unit 1 from Section A. Okay, so let's match the term from column Y with the definition in column X. So the first one says the actual values or outcomes that are recorded on a random variable, and this would be B, the data that is recorded. So that eliminates the second one. Then it says condenses data into a few summary measures. This is A, your descriptive statistics. Oh, sorry, I'm writing it under the wrong heading. Then the next one is a measure that describes a characteristic of a population. This is a parameter, so that is E. The next is the attribute of interest on which data is collected and analyzed. This is C, a random variable. And the last one is the object that's being measured, counted, or observed with respect to the random variable under study, and that naturally could only be D. So here are your answers for question 1. Any questions on question 1's theory? Okay, let's move on to question 2. So this says to you that the following grouped frequency distribution, and immediately here they've already said to you that this is grouped frequencies. So it's a grouped data question. So they said to you that the following grouped frequency distribution table indicates the number of clients per day who made a purchase from a shoe shop over a random sample of 50 days. So they've given you the number of clients that could potentially come in, and this is between 20 and less than 30, which is technically 20 up until 29, including 20, including 29. Then you have 30 to less than 40. So again here, this technically means 30 till 39 because it's still less than 40. And that's including 30, including 39, and so on. Then you have the number of days, and these are all of your frequencies. So the frequency summed up gives you, So remember the sum of F, which is also known as N, your sample size, is 50. And they said to you, calculate the following using the appropriate formula. And these were the calculations of the mode, the median, and your standard deviation. And the next question was to draw up, I think it was a bar chart, if I'm not mistaken. Yes, so they asked you to draw up a bar chart, and that was question 2. So let's have a look at this. So the first thing that you would do if you choose the option to answer your grouped data questions, the first thing you would do is draw up your formulas. So here, and this is in your formula sheet. And remember, you are working with grouped data here. So here your mode formula is OMO. I'm just going to write it out and then I'll explain. All right, so the first question says to you to calculate the mode and interpret your answer. So when it comes to your grouped data, to calculate the mode, the first thing we would need is your interval. Now, in order to identify which interval is going to give you your mode, you would simply look at this frequency column and you're identifying the group, that has the highest frequency. So the highest frequency is 23. Its respective group is 40 up until less than 50. So immediately we have done step 1. I'm just going to write that at the top here. For your mode, step 1 tells us the group that we've selected, and that would be 40 to less than 50. This is referred to as your modal group. And before we continue, I'm just going to add on an additional column here, calculating the cumulative frequencies. So the cumulative frequency is always the same for the first frequency. Then it's 4 plus the 8 to give you 12, 12 plus the 23 to give you 35, 35 plus 12 to give you 47, 47 plus 3 to give you 50. All right, so now that we have that, just want to erase the arrows here. All right, so now that we have that, we can go back to our calculation of your mode. We know that the interval is 40 to less than 50. Now to actually calculate the mode using the formula that you see up here. So this says to you that the first part of it is OMO. It means taking the upper limit of your interval, your modal interval, and that would be the value of 40 plus, then within brackets you have FM minus FM minus 1 at the top. And what I'm going to do here is, before continuing with answering or plugging in the values of this into your formula, let's look at what is FM minus 1, what is FM, what is FM plus 1, and so on. So from the formula, you would have deduced that there are 3 different things we need. We need FM, we need FM minus 1, we need FM plus 1. So FM is the frequency of the group itself, of the group 40 to less than 50. Then your FM minus 1 is of the group 40 to less than 50. Then your FM minus 1 is the frequency of the group before it. And then FM plus 1 is the frequency of the group after it. So now we have pretty much everything we actually need for the formula. So you're going to now start plugging in the values. So in your formula, it says, and remember it's here, we're working with number 2 here. So it says take your lower limit plus FM minus 1. So here's FM minus 1. So that's 23 minus 8. And then in your denominator, it is 2 multiplied by FM. Sorry, just want to erase this so I have enough space to write. So FM is the 23 minus the 8. It's at the top already. And then in your denominator, it's 2 times FM. So that's 2 times 23 minus FM minus 1. So here's FM minus 1, the 8 minus FM plus 1. And that's 12. The C on the outside, which I had included just now, but I mistakenly erased it. This refers to as the interval width. So your interval width is looking at, excuse me, it looks at the difference between the values that make up your interval. So between 40 to less than 50, which is technically 40 till 49, including 40, including 49, this would be, so you can literally count on your fingers for this. It'll be 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. So, sorry, not 50, till 49, because it's 40 till 49, including 40, including 49, because they said to less than 50. So it would be the number right before 50. So this would be 49. That gives you a value of 10 as C. So now when you plug this into your calculators, as you can see, it says 40 plus. At the top, you have 23 minus 8. And then in the denominator, you have 2 times 23 minus 8 minus 12. And then you have the 10 on the outside. You can even put the 10 into this numerator here. Just make sure you recognize that it's multiplication. So you can put it with the figures at the top. Just make sure you're saying 10 times the 23 minus 8, or you can even put it here at the end, whichever you prefer. But essentially the most common one, according to how the formula actually goes, is it's at the end here. So when you put that into your calculator, that would give you, sorry, let me just write that down. That would give you 45.77 as your final answer. I'm just erasing this here so you can see that clearly. Okay, so 45.77 is your final answer. They did ask you to interpret this, so you're going to say that, and remember this is the mode. It means, and in general, the mode is the most frequently occurring value in your data set. This is looking at the number of clients per day who made a purchase from the shoe shop. So you're going to say that the most frequently, or the most frequent number of clients who purchased from the shoe shop is 45.77. Now, I know that it is a number of clients, meaning a number of people, and rightfully it should be a whole number because we don't have decimals as people. But just for the purpose of the exam, because you are required to round off to 2 decimals, please do round it off. Don't just bring up your own rule and say to yourselves that because it's people, it needs to be a whole number and you change that. Do not change it. Although it should be a whole number because it's people, for the purpose of the exam, please leave it as is. So when you interpret as well and you say that This is the most frequent number of people or clients per day who visited the shoe shop and purchased from it. You will leave it as a decimal as well. So you'll say that the most frequent number of people who have purchased from the shoe shop is 45.77. So 45.77 people is the most common number of people who purchase from the shoe shop. Okay, so that's question 2.1.1. Let's move on to question 2.2. Sorry, question 2.1.2. So this is the median. So I've also already written out the formula for this. And it says to you here at the bottom that the median is calculated as OME plus at the top you have n over 2 minus the sum of the frequencies in the groups before the group you've selected, and then it's over the frequency of the group itself, and this is multiplied by 10. So here I'm saying 10 because the C value that you calculated here is the same as the C value that you would have used for the previous question. And it is as a general rule that it will be this way. If you are calculating values based on one data set and you saw that C was 10 the first time around, it's never going to change. It'll have to be 10 as well. So it will differ from example to example, but if you're still working with the same example and you're just calculating something else, then your C value will be exactly the same. Okay, so let's have a look at the median. Now, for your median, there are also certain steps that need to be followed. So I'm just going to erase what's on the screen so that we can work with this. I'm also going to write down the steps preceding this. So step 1 is to determine the position of your median. Once you have the position, which is calculated as n over 2, you will then determine the interval that you're working with. And then the actual calculation of your median is step 3. Okay, so step 1 is to determine the position of your median. The position of the median is calculated as n over 2. N has been given to you, as you would have seen here in the table. They said to you n, which is your sample size, is 50. So 50 divided by 2 tells you that the 25th value in your data set is your median. Now we need to locate the interval within which we will find that 25th value. This is why I included the cumulative frequency column here. So the cumulative frequency column tells you so far how many values there have been. And basically it tells you every time an interval is added on, this is what your new number of values will be. So if you look at your cumulative frequency column, you would have found the 25th value here because initially in the previous one you had only 12 values so far. When you brought in that next frequency, this is when it took you to 35. So this interval then is the same interval 40 to less than 50 that we used in the previous question with your mode. So 40 to less than 50 is your interval. I'm just going to write that here. And we're now going to start plugging into your formula. So the first part of it says OME. That's the lower limit. So it'll be 40 plus. Then within brackets, you have n over 2. That's already calculated in the first step. So that would be 25. If you would like to, you can just write 50/2 again, but it's obviously whatever you prefer. So 25 minus the sum of the frequencies in the groups before the group you had selected. So if you selected the group for theta less than 50, then the groups before it are those two, and their respective probabilities are 4 and 8. So here you're going to add up 4 and 8, and that's going to give you 12. Sorry, let me just rewrite that again. Okay, so that's your sum of your frequencies in the groups before the group you've selected, and then in your denominator, it's a frequency of the group itself. So the group you selected is for theta less than 50. Its frequency is 23. And then C on the outside, as I said, would still be the same 10 that it was for the previous one. All right, so this then would give you an answer of, so this is your median, remember, and they also asked you to interpret here. This would give you an answer of 45.65. And remember, to interpret, your median is basically separating your data set into two equal halves. It's basically telling you that this is where half of your values lie, this is where the other half lies, and here you're going to interpret it by saying that 50% of the time, this is explaining the fact that it's based on half, so 50% of the time it would be 45.65 customers or clients who made a purchase from the shoe shop. So again here, please make sure to leave it as 2 decimals unless they specify otherwise. And this is, although it's supposed to be a number of clients, which is a whole number, because they did not ask you to round off to the whole number, you will leave it as is. So that's 45.65 clients that visit the shoe shop on half of the days, or 50% of the time. All right, so that's question 2.1.2. And then the next one is to calculate, using your calculator, the standard deviation. So here your standard deviation on your calculators, and I'll talk you through it as well, how to enter this onto your calculators. You're going to need, although it's only 2 marks, you do need to obviously just write down your final answer, but you do need to know the steps involved in calculating your standard deviation on your calculator. I also, if I'm not mistaken, I think I did already upload a calculator worksheet that you can make use of, but if not, you can just take down, I will just double check on that. If I haven't uploaded it yet, I will upload it for you. I will also just take you through the steps now so that you are able to carry out that calculation. So ahead of calculating your standard deviation on your calculator, you need your midpoint. So the letter X denotes your midpoint. Your midpoint is calculated by taking the first number of your interval, adding the second number, and dividing them by 2. So 20 plus 30 divided by 2 is 25. Then 30 plus 40 is 70 divided by 2, that's 35. 40 plus 50, 90 divided by 2, and so on. So once you have your midpoint, you're going to change the mode on your calculator. So the mode button is next to the on button. Press mode, choose the option that says stats mode, then choose the option that says 1 minus VAR. Once you have that on your calculator, Because you are working with grouped data, you're then going to press Shift, which is also known as the second F. So second function, it's on the left-hand corner, the very first button at the top. Second function or Shift. Then you're going to press Mode again. Then you're going to press the down arrow. Then the option that says Stat. And then the option that says frequency on. So it should be option 1. So this is to turn your frequencies on. Once you have that, your calculator will give you 2 columns, one that says X and the other that says FREQ for frequencies. So here, under the column that says X, you're going to enter all of these midpoints that we had calculated. So you'll type in 25, press enter, or the equal button, then 35, equal, 45, equal, and so on. Then once you're done, you'll use your right arrow to navigate to the right-hand column where it says frequency. Then you're entering all of these values. I'll give you a second, but I'll write down in the meantime the next step. So here you have, I'm assuming you would have entered all of the values by now. You'll press the AC button, which is one of the 2. I think on some calculators it's a green button, on some calculators it's yellow. So it's one of the buttons that is just above your addition, multiplication signs, and so on your calculators. So AC, then Shift and the number 1. Then the option that says VAR, and then for your standard deviation, it's the option that says SX. It's a standard deviation of your sample. And that should give you 9.89 as your final answer. All right, so that's your standard deviation on your calculators. I will just have a look at whether I had uploaded that worksheet already, telling you how to use your calculators. If I haven't, then I will upload the worksheet for you as well. And in the meantime, you can just practice using the steps that I did write out on the screen. I have. Okay, perfect. Thank you. So question 2.2 was to then draw up a bar chart. This is pretty straightforward, and it really would be quite easy marks if they do give you something like this. They said that this was based on female consumers, and it was asking them which brand of soap they had used. So they have the option of Dove, Pears, and Cuticura, and they have the number of female consumers 15, 10, and 5, respectively. In total, there were 30. They asked you to draw a bar chart to graphically illustrate the results given in the table. So here, when you're drawing up the bar chart, the main mark allocation comes from firstly having a title for your bar chart as a whole. So you can just literally label it brand preference or soap brand preference. So soap brand preference, there's a mark for that. Then there'll be a mark for having headings for your X and Y axis. So the number of consumers goes on to your Y axis. The brand of soap will be your X axis. So soap brand. Then you have dove, pear, cuticure. So I'm just putting in the first letter, but you'll obviously write that out in full. And then it goes up to 15. So you can maybe go in 5. So 5, 10, 15. So the first one for dove was 15, and make sure to write the number at the top of the bar. Then the next one was 10, and then the next one was 5. Okay, so that's your mark allocation. There's a mark allocated to having a heading. There's a mark allocated to having the y-axis title and a mark for the x-axis. A mark allocated to having the y-axis title and a mark for the x-axis. So that's 3 marks already. There's a mark for having the numbers on the bars itself, that's 4 marks. And then there's a mark allocated to making sure that the bars have spaces between them, because this is what a bar chart will be about. Okay, so that is your bar chart. Any questions for question 2 as a No, you don't. If you are asked to draw up a pie chart, you can just draw it up freehand, as long as it does look as accurate as possible. But obviously, you won't lose marks for not having each circle drawn up perfectly or every part of it drawn up exactly to measurement, but it just needs to look like it makes sense. Okay, so I think we can move on to question 3. So what's important is here to note that they gave you this little block where they now said to you, give all your final probability answers to as percentages to 2 decimal places unless otherwise indicated. So please do pay attention to these little things. As I said, they generally will tell you ahead of a question whether they want you to change the final answers and how they should appear. If they don't say anything, you can just stick to your normal rule of 2 decimals. So this is based on your Learning Unit 5 content. I already interpreted them, Cameron. Please can I ask that you go back to the recording later on and listen in on that? Okay, so as I was saying, for this next one, you're going to Yes, so as I was saying, for this next one, you have Learning Unit 5 content that's being questioned here. So this is for 15 marks, and they said to you here that in question 3.1, a bag contains 12 red and 9 blue marbles, and I'm going to write this out immediately already. So the reason I'm starting right at the beginning is because it makes it much easier as you go along to then identify where your figures came from, how they will change along the line, and so forth. So they said 12 of them are red and 9 of them are blue. And collectively, that gives you 21 marbles that you're starting off with. Then they said that you are asked to select 2 marbles from the bag. The first marble selected will not be placed back into the bag. And that's very important as well, because it obviously will impact your second part of your probability tree. And then they said to you, construct a probability tree to indicate the various possible outcomes and their probabilities. And then in question 2, they said, what is the probability that the marbles will be of different colors? So here, when you are constructing your probability tree and calculating their associated outcomes and probabilities, I said to you to please try and stick to fractions in its simplest form here, only for the next question, 3.1.2, can you then convert that to a 2 decimal place percentage like they asked you to in this question, in this block. So when you are drawing up your probability tree, sorry, let me just look at the question. No, you don't have to write down the brand of soap inside the box because that would be already done on the x-axis. Remember, in your x-axis, you are writing out that these are the categories. So the first one was Dove, then Pear, and then Cuticura, and so on. So you don't need to write down the name of it, just the number on the bar. Okay, so back to the probability tree. The first part of it is looking at the first marble being selected. Remember, they said 2 marbles are selected. So let's start off with the first one. So when we are looking at the first marble being selected, you have red and blue. And we said that 12 of them were red. This is the part that I wrote down at the top here. 12 of them were red, 9 of them are blue, and collectively they are 21. So you're literally going to write that out as well. You're going to say that there are red and blue marbles. The red, there are 12 out of the 21 that are red. There are 9 out of the 21 that are blue. And that's the first part of it. The next part of it is now looking at the second marble being selected. So the first thing that you need to be able to identify is that probability trees are always based on an independent rule, or it's based on independent events, meaning that what happens the first time around does not affect what happens the second time around. So the first time around, if you selected red, you can still choose red again the second time, or you can choose blue the second time. And again, at the bottom, if you selected blue first, you can still either select blue again, or you can select red the second time. So what happens the first time around does not impact what happens the second time around at all. So now the next thing you need to identify is that they said to you that the first marble selected will not be placed back into the bag. So from 21 marbles that we started off with, which is what we had identified at the beginning, 21 is what we started off with. We now have 1 less, which means we now only have 20. So your denominator for all of these now becomes 20 because now you only have 20 to select from the second time around. Now let's look at just this portion at the top. Ignore this bottom part for now, just focus on the one at the top. So now we're looking at, if we selected red the first time around, that means from 12 red, we only now have 11 left, because if we select 1 red and it's not placed into the bag, there's only 11 red left. So if we happen to choose 11 again, there's only 11 to choose from. And if we selected red the first time, that means the blue would have not been touched at all. So all 9 blue that we started off with would still be there. So this would be 9. So that's the first part. Now let's look at the second part at the bottom. Now it's the opposite. You're going to do it in reverse. Now you're saying that if you selected blue first, then red would not have been touched at all from the start. So from the start, when we look at red, there are, and I'm going to circle it at the top here, there are 12 red. So the red would have been untouched. All 12 would have still been there. Then if you selected blue the first time, that means from the 9 blue that there were, there's now 1 less 9 available to select from. So that would now be 8 available for your blue. And now you're done with your probability tree as a whole in terms of the actual tree. Now you need to calculate the associated probabilities. So the probabilities is again coming back to the fact that your probability trees are based on the independent rule. The independent rule says that to calculate the probability of an independent event, so this is the general rule, the probability of A and B occurring is calculated as the probability of the first event A and B occurring is calculated as the probability of the first event A times the probability of the second event, which is B. So now you're going to do exactly the same thing, apply the same rule. So here you're going to say, if you selected red first and then red again, so that's the probability of red and red, that would be calculated as the probability of the first one, which is 12 over 21, multiplied by the probability of the second one, which is 11 over 20. And that would give you 11 over 35 as your answer there. Then the next one is the chance of selecting red the first time and then blue the second time. So it's the probability of red and then blue, and this would be 12 over 21 times 9 over 20. And this would be 9 over 35. Then the next one is blue and then red. So the probability of blue and then red. So that is 9 over 21 times 12 over 20. And that's also 9 over 35. And then the last one is blue and then blue again. So the probability of blue and then blue again is 9 over 21 times 8 over 20. And that's going to give you 6 over 35. So now that you're done with that, that's question 3.1 complete. Now you can move on to answering the question based on the probability in question 3.1.2. So here it says to you, what is the probability that the marbles will be of different colors? So all you're going to do is look at your final part of your probability tree that you had done and identify where you have different colors each time. So that would be the second one here, the probability of red and then blue. And then it would also be the third one, which is also blue and then red. So it cannot be the first one because the first one is red and red. Here it's red and red. It cannot be that. It cannot be this one because this is blue and blue, so those are the same colors. So it definitely cannot be those two, which means it's the middle two, and you're then going to add those probabilities up. So 9 over 35 and 9 over 35. So all you'll do then is you will say that it's the probability of red and blue, which is 9 over 35, plus the probability of blue and then red, and that's also 9 over 35, which is as a decimal 18 over 30, as a fraction 18 over 35, and as a decimal, remember they said percentage to 2 decimal places. That would be 51.43%. All right, so that's the first one there. Your probability tree as a whole, and your final answer for question 3.1.2 is 51.43%. Okay, so then question 3.2 now. This is based on incorporating your independent rule into your non-mutually exclusive rule. So it says to you, events A and B are such that the probability of A is 0.1. This was also, I think, in your assignment too. So the probability of A is 0.1 and the probability of B is 0. A or B. Sorry, let me just clear the screen so that I can read that clearly. Okay, so the probability of A is 0.1 and the probability of A or B is 0.65. Given that A and B are independent and they are non-mutually exclusive, determine the probability of B. So the first thing you need to acknowledge is that it's non-mutually exclusive and then it's independent as well. You will then write out the rule for a non-mutually exclusive event, which is the probability of A or B is calculated as the probability of A plus the probability of B minus the probability of A and B. And then the fact that they're independent means that this last bit can be broken down further. So I'm just going to write the first part exactly as it was again. The probability of A or B is equal to the probability of A plus the probability of B minus. Now this can be broken down. I just had it on the screen just now that when it's independent events, the probability of A and B is calculated as the probability of the one multiplied by the probability of the other. 1 multiplied by the probability of the other. Now we can start to plug in what we do have to work out what we don't have. We are working out the probability of B. So the probability of A or B has been given. It's the 0.65 that they've given to you here. This is what's on the left-hand side here. So 0.65 is equal to, you also have the probability of A, which is 0.1. So 0.10 is equal to, you don't, sorry, not equal to, it's plus. You don't have the probability of B, so I'm just going to leave that as is, minus, within brackets now, you have the probability of A, which is 0.1, and you don't know the probability of B still. So you're leaving that as is. So I didn't put in the multiplication sign there, as I said, because you don't need to have the multiplication sign to indicate that it's multiplication. As long as there's no sign between variables, it's a given that it's multiplication. So now you can start to open up brackets, take over to the other side until you have all of your common variables on one side. So you're going to start by taking the 0.1 to the other side. It'll say 0.65 minus the 0.1 is equal to, and then on the right hand side, you just have this probability of B. And now you can open the brackets and it will say minus 0.1 times the probability of B. So I'm just going to do it at the bottom here now. On the left-hand side, 0.65 minus 0.1 will give you 0.55 is equal to, now here, this PB is common here and here. So if it's common, you're going to leave it there. And now in front of this PB, there's an invisible 1. So now you're going to say 1 minus 0.1, which would give you 0.9. So 0.55 is equal to 0.9 PB. You want to calculate the probability of B, so you're going to get rid of the 0.9. It was multiplication, so on the other side, it will now become division. So 0.55 divided by 0.9 will tell you that the probability of B is as a percentage to 2 decimal places, which they asked you for, is 61.11%. All right, so that's question 3 done. Any questions there? Okay, let's look at question 4. So this is based on your learning unit 6 and 7 content. So pretty much what you can expect in section C of your exam. This would be one question based on learning unit 6 and 7. In fact, this and learning unit, and question 5 here is also based on learning unit 7. This whole thing is a typical type of question that you can expect from those 2 learning units. Okay, so let's look at question 4. It says to you that it has been found from experience that there is an average of 3 typo errors per 10 pages printed in the British weekend newspaper. So the average of 3 immediately says to you that this is a Poisson distribution. You have your average, which is 3. Then they say to you, if we randomly selected 10 pages from a copy of this newspaper, what is the probability that there will be more than 3 typo errors, and interpret your answer? So here, the more than 3 immediately says to us that we're looking at the probability of x being greater than 3. Now here, because we know that it is, and I'm going to write it on the side here, we know that it is a Poisson distribution. The formula for a Poisson distribution is e to the power of minus a multiplied by a to the power of x over x factorial. And with the Poisson distribution, there's no n value. There's no sample size. So I'm going to say here, remember, there's no n, meaning that if we say for the probability of more than 3, that means it will be 4, 5, 6, 7, 8, 9, 10, and it will continue into infinity. So because we obviously cannot go that route because we wouldn't know where to stop, we then use the complementary rule. So here, as long as you're working with a Poisson distribution and it's saying more than, you will always use the complementary rule. So this will say 1 minus. The complementary rule, remember, is 1 minus the opposite. So that would be 1 minus the opposite of greater than 3, which would be the probability of x being less than and inclusive of 3. So the probability of x being, sorry, I just want to erase this from here so that you can see that. The probability of x being greater than 3 is calculated as calculated as 1 minus the probability of x being less than, which is the opposite of greater. So less than and inclusive of 3, because 3 wasn't included on this side. So now if we're saying less than and inclusive of 3, that would mean, now if we're saying less than and inclusive of 3, that would mean we are saying that it's 1 minus the probability of x being less than and equal to 3 is 3, 2, 1, and 0. So it'll be the probability of x being equal to 0 plus the probability of x being equal to 1 plus the probability of x being equal to 2 plus the probability of x being equal to 3. So now let's do this. You can actually do it as one calculation, as one whole formula. This is the formula, remember, I wrote it here on the side for you. E to the power of minus a times a to the power of x over x factorial. X is going to be 0 first, then it'll be 1, then it'll be 2, then it'll be 3, and then a is here already given to you, and that is 3. So it'll be 1 minus, remember exactly as you wrote it out here, it'll be 1 minus, and then now you can just do it within brackets as one fraction, as one formula. So it'll be e to the power of minus 3, that's your a, times 3 to the power of, the first time around x is equal to 0. So it'll be 3 to the power of 0 over 0 factorial. That's the first one done. Plus, now let's make x equal to 1. So it'll be e to the power of minus 3 multiplied by 3 to the power of 1 over 1 factorial. Then it will be e to the power of minus 3 multiplied by 3 to the power of 2 over 2 factorial. And the last one is e to the power of minus 3 multiplied by 3 to the power of 3 over 3 factorial. And this then is going to give you your final answer when you plug that into your formula. Oh, sorry, when you plug that into your calculator, will give you an answer of 35 point, so it'll give you 0.3528, which is 35.28 as a percentage. So when you're interpreting this, you're then going to interpret it exactly from the question. So the easiest way to do this is take your answer and plug it into the question so that it reads as a closing statement. So you will say that the question said, what is the probability that there will be more than 3 typo errors? You will literally use that exactly as it is with your answer. You will say there is a 35.28% probability that there will be more than 3 typo errors. So always just look at the question when you need to interpret and take your answer, plug it in, and let it read such that it's a closing statement. Okay, so that's question 4.1. Let's have a look at question 4.2. So for question 4.2, it says it has been found that the income per month in South Africa is normally distributed. The moment you see the words normally distributed, it says to you it's a content from Learning Unit 7. It's your sampling distributions. So it says to you that the income has been normally distributed with an average income of 13,044 and a standard deviation of 1875. What is the probability that a randomly selected South African earns, firstly, an income between 12,500 and 14,000, and interpret your answer, and then an income between 11,500 and 12,750, and interpret your answer. So here, from the information given to you, the first thing we need to note is that they've given you the population value, 13,044. They've given you the standard deviation, it's 1875. And they also, in not so many words, gave you your sample size. They said, what is the probability that a randomly selected South African? So that told you that n is equal to 1. It's one single person. Then the next thing you're going to do, let's work with question 4.2.1 first. The first thing you're going to do, it says that we're looking at what's the probability that a randomly selected person will earn an income between 12,500 and 14,000. So it's a 3-step process for Learning Unit 7. The first thing you're going to do is draw up your bell-shaped curve and plot your population value down the center. Your population value is the 13,044, so 13,044 goes in here. Then you're going to plot, so that's your population value, which is the letter, so this is called mu in scientific notation. Then you have your x bar Hi guys, can you hear me? Okay, perfect. Sorry about that. Load shedding kicked in, so it just took a minute to get back onto Blackboard. Okay, so let's continue. Can everyone hear me? I'm just waiting for the document to load on my side. Load shedding just kicked in, so it is a bit on and off. Okay, there we go. So let's continue with where I stopped off. I had said to you that you would plot then your X bar values onto the diagram. So the 12.5 would fall somewhere on the left, so that would be somewhere here. And then the 14,000 would be somewhere on the right-hand side. So now that you have your values plotted out, the rule then is if the values fall on either side of the central line. So here's your central line here. And as you can see, both values are on either side of that central line. The rule then is addition. So at the end, when we get to our final answer, we know that we're going to be saying one plus the other. So I'm just going to write down the rule here at the end. So the probability will be one plus the other. Now that we know the rule, that was step one, let's do step two, which is to calculate your test statistics. Now, because we are working with an average or mean, the formula we will be using is Z being calculated as x bar minus mu over the standard deviation over the root of n. Now, this formula is in your formula sheet, but you obviously again need to know that it is applicable here. So here you have the first time around, Z will be calculated with X bar being the 12,500. The second time around, it will be calculated as 14,000 as the X bar. So let's get started with that calculation. It's X bar, so the first time we'll make 12,500 X bar, then we'll make 14,000 X bar. Then it's minus mu, so here's mu, the 13,044, so it'll be minus 13,044. Then it's over the standard deviation, which is 1875. Over the root of n, and we said n is 1. So the root of 1 is 1. You don't actually need to put that into your denominators, but if you want to, that's fine as well. So that's going to give you minus 0.29 here for the first one. And then here it is 0.51. So that's step 2. And part of step 2 is to take this Z value and you're going to go to table 1 of your appendix and you're going to determine what the respective probability is. So you're going to take this minus 0.29 together with the, sorry, I'm just trying to highlight it. Okay, the highlights of functions not working. Okay, so the minus 0.29 and the 0.51. You're going to take that to table 2 of your appendix. So again, this is given to you. You don't need to actually have or know your figures from table 2 of the appendix. I'm going to try and project it for you. Hopefully it will come through and reflect on your side with the load shedding. So table 1 is the one here. So remember we have minus 0.29 and then 0.51. Now remember with your tables, if you had a negative value like we have here, the minus 0.29, you will just ignore the minus sign and read it as 0.29. That's because your tables don't have negative values, so you are not concerned about the negative sign. So minus 0.29 and then the other one is 0.51. The minus sign, just ignore it. So you're looking for 0.2 going across, coming down the first column. So here's 0.2. And the 9, there's always a 0.0 ahead of that last digit. So it'll be 0.09. And here's 0.09 here. So this is going to be in line with 0.2 going across and then 0.9 coming down. It's 0.1141. So I'm going to write down here that its respective p-value is 0.1141. Then for the second one, it was 0.51. The 0.5 you're going to again read down. So here's 0.5. And then the last digit, which is the 1, there's always a 0.0 ahead of it. So it'll be 0.01. That's here. So in line with 0.5 and 0.01, it's this 0.1950. So here the respective probability is 0.1950. Now you have your probabilities. You're going to take these two values back to the question. So let's go back to the question. And remember we said that we identified when we were working with the question that at the end it would be the addition rule. So we're now going to add them up. So let's write these back down here. So this was 0.114 down here. So this was 0.1141 and that was 0.1950. Now you're simply going to take those two values and add them up. So 0.1141 plus the 0.1950, and that's going to give you a value of 0.3091, which is 30.91%. Okay, and that's your final answer. So now to interpret that answer, Remember, take your answer and plug it into the question so that it reads as a closing statement. So the question said, what is the probability that a randomly selected South African earns an income between 12,500 and 14,000? You're going to say that there is a 30.91% probability that a randomly selected South African earns an income between 12,500 and 14,000. And that's your answer for the first one. Let's look at the second one now. It's exactly the same thing. It's just that the rule is a bit different. So it says an income between 11,500 and 12,750. So draw up your bell-shaped curve. The 13,044 is down the center. 11,500 and 12,750 would both be on the left-hand side. So 12,750 should be somewhere here. This then, as long as it's on one side of that central line, is the minus rule instead of the addition rule. So at the end just now, when we calculate their probabilities, it's going to be minus instead of plus. So you're going to do the same next step, calculate two separate Z values. The first time around, X bar is 11,500. The second time, it's 12,750. So here it's 11,500. Here it's 12,750. Minus mu is the 13,044. It's actually exactly the same information as well that goes into the formula, except that X bar is different and the rule is different. So this is over the standard deviation of 1875. As I said, you don't have to put in the root of 1 if it is 1 as your sample size, because this will give you 1. And you don't have to write 1 in the denominator. So this will give you, the first one is minus 0.82. And then this is minus 0.16. So now you're going to read it off the table as well. I'm just going to give you the probabilities here because you should be comfortable with these on the table by now. So remember, read 0.8 coming down the first column, and then the 2, there'll be a 0.0 ahead of it. So it'll be 0.02, and you'll read that going across. So in line with the 0.8 and the 0.02, that would be the 0.2939. And then here, read the 0.1 going down. And then the 6 would be 0.06, and it'll be red going across. So in line with 0.1 and then 0.06 going across, that's 0.0636. So now you're going to always take the larger of the two values, and that's the 0.2939 minus the smaller. That's because probabilities can never be negative, so it'll have to be the higher minus the smaller, and that gives you 0.2303. That is 23.03%. So to interpret now, you'll say there's a 23.03% probability that a randomly selected South African will earn an income between 11,500 and 12,750. All right, so that is your question 4 as a whole. Any questions there? Yes, that would be correct. So it's either Learning Unit 5 or these two, Learning Unit 6 and 7. Okay, so let's look at question 5. This is also based on Learning Unit 7. It says experience has shown that the value of orders placed by by customers of Help Yourself Pty Limited is normally distributed. Again, the moment you see the words normally distributed, it says to you, you're going to draw up your bell-shaped curve, and down the center, you're going to plot your population value. So they said to you then, in terms of your population value, that it is, they said, with an average order value of 1,150. So that's the 1150 that will go down the center here. And a standard deviation of 125, a sample of 145 orders is randomly selected. So N is 145, your mu is 1,150, the standard deviation is 125. And let's look at the question. It says determine is 125. And let's look at the question. It says determine the standard error for the sample. The standard error is the denominator of this formula, if it's an average that you're working with. So this part here, the standard deviation over the root of n, that's what you're calculating in question 1 here. So your standard deviation is 125 over the root of n, which is 145, and that gives you an answer of 10.38. Okay, so this is in rand, so try and stick to using that unit of measurement if possible. So 10.38 is your first answer. Then the second one says to you, what is the probability that the mean value of the orders in the sample is more than, and I'm going to underline that part specifically, more than 1146. So the first thing you're going to do is acknowledge that the 1146 is your X bar value. The second thing you're going to do is plot that 1146. That would be somewhere here. And then you're going to look at the word more than. More than 1146 means you're moving in this direction. And as long as you're moving towards that central line, and as you saw here, we move towards it and past it, the rule is 0.5 plus. So at the end now, again, when we get to our final step, we're going to say that the probability is calculated as 0.5 plus, and we'll now have to work out what we're adding on. So here, we now know the rule. We can calculate the Z value. So the Z value using this formula, it's X bar, which is the 1146, minus mu, which is the 1150, over the standard deviation of 125, over the root of n, which is 145, and that gives you minus 0.39 as your Z value. Now you'll go to table 1 of your appendix, exactly like you have done. Get a p-value, a probability. So the 0.3, you'll read going down the first column. And the 9, it'll be 0.09, and it'll be read going across. So in line with 0.3 and 0.09, you will get a probability of 0.1517. That now is the value that you will add here. So it'll be 0.5 plus the 0.1517, which is 0.6517, which is 65.17%. So now to interpret, you will say there's a 65.17% probability that the mean value of the orders in the sample is more than 1146. All right, any questions with that one? Okay, let's look at question 6 then. So this is learning unit 9. So this is your chi-squared distributions or your chi-squared tests. It says we wish to determine whether there is a relationship between gender and the preferred insurance provider. A survey of 300 South Africans produces the following results. They've given you a two-way table that has the 3 options of the provider. So that's 3 different options: Momentum, Liberty, Discovery. And then in terms of gender, there are 2 options, which is male and female. So that would mean that there are 2 rows of options and there are 3 different columns of options. And I'm pointing that out here because we would need that for our critical limit, to determine our critical limit. So let's read the question then. They said to you, sorry, I'm just waiting for it to load on my side. Okay, so it says perform an appropriate test at the 5% level of significance to determine whether there is a relationship between gender and the preferred insurance provider. So we know that it's a 5% level of significance, and we know that we're testing for a relationship that exists. So the first thing you're going to do with with your chi-squared tests is write out the null and alternate hypotheses. So I'm going to write that at the top here. Whenever you're testing whether there is a relationship or whether there is independent or statistical association, your null must always say that they are independent, meaning there is no relationship between the variables. So your null then would say that there is no relationship between gender and the preferred insurance provider. And your alternate must say the opposite of that, always. So your alternate will say that there is a relationship. There is a relationship. There is a relationship between gender and the preferred insurance provider. Okay, so you have your null and alternate hypotheses. Step 2 now is to determine your region of acceptance and rejection. So with a chi-square test, it's always ever one-sided and upper-tailed. So here, this is only, remember, the diagram is only for your personal use. It's only to help you visualize where your region of acceptance and rejection is. You do not need to actually draw this for marks. So here, with the chi-square test, it's only one-sided upper-tailed. So there would be one critical limit on the right-hand side here. Your region of acceptance is everything including that value and less than it. Your region of rejection is everything greater than it. Now, to get to that actual value, that critical limit, you needed 2 things. Your level of significance, which they gave to you, they said it was 5%. It was on the next page at the top. Here it is here. So as a decimal, that's 0.05. And then you also needed your degrees of freedom. The degrees of freedom for a table like this one here is calculated as the number of rows minus 1 multiplied by the number of columns minus 1. Now, I already said to you that there were 2 rows that had information, and there were 3 columns that had your relevant information. So that's 2 minus 1 multiplied by 3 minus 1, and that gives you a degree of freedom of 2. Now you're going to take that 2 and that's 0.05, and you're going to go to table 3 of your appendix. So I'm going to try and project it for you. Hopefully it will work. So table 3 of your appendix is your chi-squared or your your chi-squared test or your chi-squared distribution table. It has all of the factors that are only specific to chi-squared tests. So 0.05 and 2, you're going to take those to the table. The 0.05 will be read going across. The 2 will be read coming down the first column. So let's look at that. Okay, it's giving me a bit of a problem, but let me just try it again. Okay, I think it should work now. Okay, there we go. So you're looking at, remember, A is 0.05. I told you you'll read this going across. The degrees of freedom is 2. Okay, that just disappeared. Sorry, I'm not sure what happened there. Okay, there we go. So yes, A is your 0.05. Degrees of freedom is 2. So that's across, this is down. So 0.05, here it is here. And then degrees of freedom is 2, here it is here. So in line with that and that, 5.991 is your critical limit. So we're going to take that 5.991 back to our question. That is your critical limit. But now remember I said to you, you need to actually write this out in words. The diagram is not what you are required to do. So in terms of your diagram, we'll put in the 5.991, but we'll write it out in words. So here's the 5.991 here, but you now need to write out your region of rejection. So you're going to say, reject the null hypothesis if the chi-squared statistic is, and reject we said would be if it's greater than. So is greater than 5.991. So you'll write that out in words. Obviously, you'll write it out as a sentence. I just don't have space here. So I'm writing it down in that small space. But you'll just say, reject the null hypothesis if the chi-squared statistic is greater than 5.991. All right, so we now have your step 2 done. Step 3 is now to determine your actual chi-squared statistic. So to calculate your chi-squared statistic for a table like the one that you see at the bottom here, you will be required to redraw the table. So to redraw the table, I'm actually going to, let me just see if I have space here. Okay, so I have space at the bottom of the next page. I'm going to redraw it here. So you need a column for your expected frequencies, your observed frequencies, and then in the last column here, and I will write this out more clearer on the previous page just now. So whatever information you're given in this table are your observed frequencies. This is just as it is. It's always observed frequencies being given to you here. So you're going to, and I'm going to start with the first one here. Females and momentum is 12, female and liberty is 24, female and discovery is 61. So 12, 24, 61. So I'm going to write here that for females, for momentum, it was 12, liberty was 24, discovery was 61. Then we're going to do the males as well. So momentum, liberty, discovery. Let's go look at what those were. Males was 65, 63, 75. Was 65, 63, 75. 65, 63, 75. Okay, so now you're going to calculate the expected frequency. So the expected frequency is calculated by firstly looking at which is the first one you're starting with. So you're starting with female and momentum. That's the 12 in the table. So you're going to go to, remember, there's the 12. In line with it, its row total is the 97. Its column total is 77. So 97 times 77, and that's divided by the sample size of 300. So 97 times 77 divided by the 300 gives you 24.9. So that's the first one here, 24.9. Then the next one is liberty. So here you're going to take, here's liberty. Its row total is 97. Its column total is 87. So 97 times 87 divided by 300. And that gives you 28.13. Then the next one, and I'm just going to do this last one for here. Then I'll write the others, the answers to the others, because it's the exact same process. So the next one is 61. Its row total is 97. Its column total is 136. And that's divided by the sample size of 300. So that will give you 43.97. And then the rest of it is the same. So I'm just going to write down those answers. It's just row total times column total, and then divided by your sample size. The denominator always stays the same. It's the numerator that changes. Okay, then here the last column is saying take your observed frequency minus its expected frequency and square that whole bracket, and then it's over the expected frequency. So I'll just do the first two, and then the same, it'll be the same for the rest of them. So the first one is 12 minus its respective expected frequency of 24.9, square that whole bracket over the expected frequency of 24.9, and that is 6.68. Then the next one is 24 minus 28.13 squared over 28.13, and that is 0.61. And then the rest of them are the same. So 61 minus 43.97 squared over 43.97, that's 6.60. Then the next one, 65 minus 52.1 squared over 52.1, that's 3.19. This is 0.29, that's 3.15. All right, so once you're done with this, you're just going to add up that last column. So when you add it up, it gives you 20.52. I'll write it out here as well. Your chi-squared statistic is 20.52. So now all you're going to do for the next step is look at where that 20.52 will fall on your diagram here at the top. And this is why I said to you, it's useful to you to have the diagram drawn up, because then you can identify where it falls. So the 20.52 would be somewhere on the right hand side here, and that's your region of rejection, as you can see. So you will then state that you will reject the null hypothesis, and then you'll explain what that means. So this indicates that, and go back to your null. If you are rejecting the null, then that's not true. The alternate will then be true. So the alternate says that there is a relationship between gender and the insurance provider. So you'll say this indicates that there is a relationship between gender and the preferred insurance provider. And that's your answer. It obviously is a bit of a process. It is a long process. So you can see that from the mark allocation as well. But obviously, remember, in terms of your mark allocation and your time allocation, it's a mark a minute. So it's 120 marks for 2 hours, which is 120 minutes. So it would be a mark a minute. Please make sure to pay attention to that and use that time wisely. Don't spend more time on something that shouldn't unnecessarily have time spent on. So this is question 6.1. You have all 5 steps done. You concluded and you said that you will reject the null, and that means that there is a relationship between gender and the preferred insurance provider. Okay, that was question 1. Let's have a look at question 2 now. So this says to you that the marketing manager of a soap manufacturing company wishes to know whether the 3 different hand soaps that they produce are equally popular. Now, this equally popular means that they would be spread equally, and I'm going to explain that to you again just now. So then it says to you, a random sample of 900 consumers was asked to choose their favorite from the 3 soaps, and this was the result. Remember, these are your observed frequencies. And now looking at this table, it's slightly different from the one at the bottom here, because it is not a two-way table. There's no 2 categories like you saw here. It's just one category. So when there is only one category, it is not a two-way table, and you'll see how what the difference between the 2 is just now. So the 5 steps are exactly the same. The only difference is going to be when you are looking at your critical limit, because your degrees of freedom will be different, and the rest of it is pretty much exactly the same. So they said to you, using a 1% significance level, test whether the soaps are equally popular. So here you're testing for equality of proportion. So when you write out your null hypothesis, it must always say that they are equal. So you'll say the soaps are equally popular. And your alternate must always say that they are not equal. So here you'll say that the soaps are not equally popular. So that's step 1 out of the way. Step 2 now is to draw up your bell-shaped curve and look at your region of acceptance and rejection. So that's your region of acceptance, that's your region of rejection. Now to get to your critical limit, you need A, which is your level of significance. It's 1%, so it'll be 0.01. And your degrees of freedom for a table like this is calculated as n minus 1. So as opposed to the one in the previous page we did just now, that was r minus 1 times c minus 1. But here, because there's only one category, it will be n minus 1, and n is the number of options you have here, which is 3 options. So that would be 3 minus 1, which is 2. So now you'll take 2 and 0.01 to your table 3 of your appendix. So again, I'm not going to project that because you do know how to read off those tables. 0.01 you'll read going across, and the degrees of freedom you'll read coming down. So in line with that, your level of, your critical limit for that one will be 9.210. So the 9.210 you'll write down here. But again, you will write this out in words. So you'll then say, reject the null hypothesis if the chi-squared statistic is greater than. So if it's greater than 210. All right, so that is your statement of rejection and how you'll be able to identify whether to accept or reject later on. And now we can move on to step 3. So step 3 is to now calculate your test statistic. So it's done in the same way that we did calculate the other just now. So you have your SOAP in the first column, you have your observed frequency, which is the one given to you, and then observed minus expected squared over the expected in your last column. So you have rose, lemon, and citronella as the 3 options. The figures given to you here, the 410, 240, and 250 are your observed frequencies. And then your expected frequency here, and this is why I was saying to you, I'll come back to this, where they said they want to know if the soaps are equally popular. So you're going to now say that if it's 900 people in total, and this is also from the table here itself, equally popular means you will split the 900 over all 3 soaps, and that will give you 300 as your expected frequency for 3 soaps, and that will give you 300 as your expected frequency for all of these, for each of these. So it'll be 300 as your expected frequency for each one. And now you have everything you need to calculate the last column. So remember, it's your observed frequency. I'll just do the first one. That's 410 minus your expected frequency, which is the 300. So 410 minus 300 squared over the 300, and that would give you 40.33. Then the next one is 240 minus the 300 squared over the 300, that will give you 12. And then 250 minus the 300 squared over the 300, and that would give you 8.33. Now you'll add up that last column, it gives you 60.66. And again, you'll now look at where that falls. That will be somewhere on the right, definitely. So this is your region of rejection. So now when you are interpreting, you will now say that you reject the null hypothesis because it fell into the region of rejection. So reject the null hypothesis, which indicates that. So if you're rejecting the null, that means the alternate is true. And the alternate says that the soaps are not equally popular. So you'll say this indicates that the soaps are not equally popular. Okay, and that's question 6 done. Any questions there?
Hi, Akila, can you hear me?
Yes, I can.
Can you please go back to question 6.1?
Sure. Are you talking about the
Okay.
answer?
Yeah. The answer, please.
The answer was removed from the screen. So whenever
Oh,
you erase something, delete it. But tell me what you're looking for.
when you put on those stuff in the first column, like female momentum, liberty, discovery, then male momentum, liberty, discovery, could you write it the other
Mm-hmm.
way around, like momentum, female, male, liberty, female, male, discovery, female, male, or does it not matter?
It should give you the same answer. I don't think it'll matter.
Okay, thank you.
But generally, if you do have this type of question, always start from this here from the first
So
category
you
in your
use that as
rows.
like the X variable kind of.
Yes, so you'll start with females and then you'll list out, like we said, momentum, liberty, discovery, and then you'll go to the next row.
Okay, thank you.
No problem. Any other questions for for question 6? Okay, let's move on to question 7 then. So this is learning unit 2. So this is your linear regression and correlation analysis. This is honestly one of the easiest sections of the module. And again, its advantage is that it is one of the compulsory ones because it does make it easy for you to score those marks. So this says to you, the following table indicates the years of experience of a sample of salespeople of We Other People, PCY Limited, and the income earned last month by each salesperson in the sample. So they've given you the X variable, the years of experience, and the Y variable, which is your income earned. They told you that it's in thousands of rands, but you will work with it as these figures that are in the table. Please do not add on the zeros for your calculations, only where you need to. And I'll explain to you just now where you might need to. Only when they specifically ask you a type of question will you need to convert it into thousands of rands. But for your main calculations, whether it's A or B in the formula, whether it's R or R squared, you will leave it as is. So it says to you, by completing the table given below and then applying the relevant formula, determine the linear regression function for this bivariate data set. Do not change the unit of either variable from the way they are given in the table. So this is the same thing I was saying to you. Please don't convert them to the thousands. Leave them exactly as they are in the table. Okay, so they've given you the table here, which is again quite advantageous because you obviously would need to know which columns to include if they didn't tell you that this is the format of the table. So here, they wanted you to complete this table and then use the information, and they said apply the relevant formula and calculate the linear regression function. So I'm going to just complete the table here because we have the X and Y columns done already. So I'm just going to add on one column for X squared here, and then I'm going to include a column for XY in between here. Okay, so X squared is literally taking the X values and squaring them. So 13 squared is 169, 12 squared is 144, 5 squared 25, 10 squared 100, 11 squared 121, and 19 squared 361. Then xy is literally just each x value multiplied by its respective y value. So 13 times 33, and that's 429. Then 12 times 39 is 468. Then 5 times 26 is 130. 10 times 21 is 210. And 11 times 31 is 341. The last one is 608. So now that you're done with that, you're going to add on one additional row at the bottom so that you can calculate the sum of each of these columns. So this is the sum of y. This is the sum of xy. This is the sum of x. And this is the sum of x squared. So when you add up all these values, the sum of y, that is 182. The sum of xy is 2,186. The sum of x is 2,186. The sum of x is 70. And the sum of x squared is 920. So now that you have that, you can calculate the values of A and B. Remember, you will always start with the value of B first. So the formula for it is in your formula sheet. So it's N multiplied by the sum of xy minus the sum of x times the sum of y over N times the sum of x squared minus the sum of x then squared. So N is how many values you are given initially. So that would be 6 as your value of N. Please make use of your brackets wherever it's multiplication involved. So it's N times the sum of xy, which is this 2186 from above here, minus the sum of x, 70 times the sum of y, which is 182. Then it's over N times the sum of x squared. So this is the sum of x squared, 920, minus the sum of x, which is 70 squared. So this would be 0.61 as the value of B. And remember, the reason we calculate it first is because for the formula for A, which says the sum of y, we need B because it's the sum of y minus B times the sum of x over N. So the sum of y is the 182 minus it's B, which is 0.61 times the sum of x, which is 70 over N, which is 6. And that is 23.22. So now to put it into the formula, it'll be y is equal to A plus BX. And I said to you the only time, so that was actually the final answer for this question, but the only time you'll ever have to convert to thousands of rands, and this was in your assignment too as well, is let's suppose that they said to you, determine or estimate what a person's income would be if they had maybe 20 years of experience. All you'll do is substitute for 20 in that final formula. So it would be, for example, y is equal to 23.22 plus 0.61 times 20 now in place of x. Whatever answer you get here, and I don't have a calculator with me, so I won't be able to calculate this, but let's just suppose that the answer ended up being 33.41. All you'll do is now you'll multiply that by 1,000, so it can be in thousands of rands, and that will give you 33,410. That's the only time you'll ever need to convert that to thousands of rands. Otherwise, please leave it exactly as it is. Okay, so that's question 7. That's pretty straightforward. Any questions on that one?
Sorry, Akila. I've got the 2019 paper in front of me, and for the x and y variables, for the x it has time. It's got a table with time period and profits in millions of rands, and the time period goes 2017 quarter 1, 2017 quarter 2, 2017 quarter 3, 2017 quarter 4. What would you use as your x values if this came up as a question?
Okay, so that is actually something that they no longer test. It's no longer part of the module. But if you had to, so you said it started in what year did it start in?
2017.
Okay, so 2017, quarter 1, 2, 3, 4, and then it'll go to 2018, quarter 1, 2, 3, 4, and so on.
Yes.
So all you'll do is you'll make these equivalent to normal numbers. So it'll always be your x variable for time. So this will be 1, 2, 3, 4, basically period 1, 2, 3, 4, and then you'll continue 5, 6, 7, 8, and so on. So 2018's first quarter becomes period 5. 2018 second quarter becomes period 6, that kind of thing.
Okay.
So you'll just
Yes.
in a normal order, but generally they will give it to you in this way. We generally don't work with time series any longer.
Okay, thank you.
No problem. To answer your question, Rochelle, they won't always specify. You might find that they might not tell you which is X and which is Y, but the easiest way to identify that is just ask yourself which variable depends on the other. So in this example, you're going to ask yourself the question of, does a person's number of years of experience depend on their income, or does the income depend on the number of years of experience? And then it becomes pretty clear to you that income depends on the years of experience. The more number of years of experience you have, generally, the higher your income is. So it becomes quite obvious then once you ask yourself that question, which is the dependent, and that would be Y, and then the independent would be your X variable. So just ask yourself that question of, like here I said, does income earned depend on the years of experience, or does the years of experience depend on the income earned? And then it'll be easy for you to answer that question and then identify which depends on which. The dependent one is Y, and then the other would be your X variable. Okay, so let's have a look at the last question then. So question 8 is based on learning unit, I think this is, I want to say it's 2, learning unit 2, if I'm not mistaken. The linear regression was learning unit 4. I think I mistakenly said that was learning unit 2. So this is learning unit 4. And then the index numbers here is learning unit 2. All right, so this is saying to you that the following table indicates the unit prices in rands and quantities of 3 goods consumed every month by a household for years 2020 and 2022. So in the table, they've given you the 3 goods, bread, milk, and bleach. They have 2020, which would naturally be the earlier of the years. So that would be your base year. And automatically its price and quantity be your base year. And automatically its price and quantity is P0 and Q0. The 2022 year then would be your current year, and its price and quantity is automatically P1 and Q1. So then they said to you, using the base year, using 2020 as the base year, compute the price relatives in 2022 for bread and bleach and interpret your answers. So here, only for bread and bleach, and remember your price relatives is calculated as P1 over P0, and it's multiplied by 100. And this is for bread. It would be, so I'm going to do bread at the top here. P1 is 19.7. P0 is 13.7. So 19.7 over 13.7, and that's multiplied by 100, and that would be 143.80. Remember, don't put in your percentages here. And then the next one was bleach. So this would be 33 over 29. And this one would be 113.79. Okay, so here you then are going to interpret. So you're going to say then for the first one, bread, you will say that between 2020 and 2022, the price of bread had increased by 43.8%. And then for bleach, you'll say between 2020 and 2022, the price of bleach had increased by 13.79%. So that's question 1. Please don't forget to interpret those. And then question 2 says, again, using 2020 as a base year, compute the partial quantity index for all of the goods for 2022 and interpret your answer. So the formula for the partial quantity index is the sum of P1 times Q1 over the sum of P1 times Q0. And this will be multiplied by 100. So here now, remember this has to be done as one long formula. Do not separate them, do not do them individually and then add them up and so on. A lot of people made that error in their assignments. Please remember it's done as one single formula. So in your numerator, it's all of the P1 times Q1 individually and then add them up. And then the same for your denominator. So for the numerator, P1 times Q1 for the first item is 19.7 times 35. So 19.7 times 35 plus. Next item is 29 times 22 plus the next item is 33 times 6. Okay, then that's your numerator done. Now your denominator says P1 times Q0. So P1 for the first one is the same 19.7, but it's times Q0, which is 30. Then the next one is the same 29 times 25 now. And the last one is 33 times 5. Okay, so that then on your calculator gives you a final answer of 103. So now when you're interpreting, remember you have to give a full explanation here. You will say between the years 2020 and 2022, the average, so between 2020 and 2022, the average quantity consumed, of the items in this basket has increased by 3%, and this is under the partial quantity index where we held prices constant. So you'll say under the partial quantity index, you can even start with that. You can say under the partial quantity index, between 2020 and 2022, the average quantity consumed of the items in this basket has increased by 3%. All right, so that is it for question 8 and for the paper as a whole. Are there any questions from you for question 8 or any other general questions? Okay, so I take it there are no questions. Thank you, everyone. Good luck for your exam. Please make sure that you listen in on this as soon as you're able to before your exam. I would suggest working through the paper again just as practice. As I said, it is exactly the same type of questions, just obviously with options available. And then all of those revision worksheets that I've uploaded as well, I also uploaded the solutions to them. So please do have a look at those as well. And if you haven't already done so, just a reminder to download this paper so that you can work with it. If I'm not mistaken, the one that is on the portal that you have access to, I think those are the second sitting. So they're not the first sitting of the paper. So just use this one to practice because it was the actual exam that was written last year. Good luck for your exams. Happy studying and take care. Bye, everyone.